Okay, so we're looking at partial fraction decomposition, and we know that the goal here is to integrate rational functions. We've seen the 4 different cases, and each case really what we're looking at is how the denominator factors. In this scenario, we have the denominator factoring into only linear terms, so this is actually case 1, and what we're going to focus on here is how to set up our decomposition, and then mainly how to focus or how to solve for the constants a, b, c, d, and so on that we get in the decomposition. So first, anytime we have a rational function like this, we check, do we need to do long division? We look here. The numerator in this case is degree 1. The denominator is degree 2. So the numerator has a smaller degree than the denominator. We don't need to do long division. So we can go right ahead and look at doing partial fractions. So we know we have these 2 terms in the denominator, and let's now forget about the integral. We'll come back and deal with that afterwards. But we know we have these 2 terms, so we're going to get 2 different fractions. 1 divided by x plus 7, 1 divided by x minus 2, and here we'll have an a, here we'll have a b. So the idea now is we want to learn how to solve for a and b. Okay, now the algebra involved in this one's not going to be too bad, but I want to focus on the 2 different methods. Okay, so method 1, this is the one we're going to use most often. It's the easiest one, and it works most of the time. Okay, method 2, we're sort of going to have to use once the questions get more complicated, once we start having not just linear terms in the denominator, when we start looking at case 3 and case 4, where we have irreducible quadratics here in the denominator, this method is going to fail us. We will not be able to find all of the constants a, b, c, and d as easily. Okay, and so let's look at the first method, and really what we do with the first method is that we're going to simply multiply both sides of this equation by this common denominator, x plus 7 times x minus 2. So we have here our equation, and we're going to multiply both sides by this. Now the goal is obviously so that those cancel each other out, but now we want to see what happens on the right hand side. So we have here a divided by x plus 7 plus b over x minus 2, and this whole thing is going to get multiplied by this x plus 7 x minus 2 term. And really, on the left, we end up with just that numerator, 8x plus 29, and on the right, we take this first term, a over x plus 7, and we're going to distribute it. It gets multiplied on both of these. So in this case, the x plus 7's cancel out, and you end up with just a times x minus 2. In the second term, we take b over x minus 2, and again, we multiply that, and this time the x minus 2's cancel out, and we just have b times x plus 7. And that's the first step. So getting to this equation, this is going to be where you now choose to use either method 1 or method 2, or you're going to choose to maybe mix the 2 together. Okay, so this is our main equation that we'll be working with. Okay, so looking at this, we have our equation, and it's one equation, 3 unknowns. We want to solve for a and b. So we recognize one main thing. These 2 sides have to be equal to each other for every value of x. So we can be smart about the values of x that we plug in. And in particular, if we use something like x equal to 2, that's going to make this term here 0. And so not only will x be gone, because x will be 2, but we'll also have that a will be multiplied by 0, and so there will no longer be an a in this equation or an x. There will only be this variable b left over, and we can then easily solve for b. So if x is equal to 2, the left-hand side of this equation, we have 8 times 2 is 16, plus 29 is equal to a times 0, plus b times 2 plus 7 will be 9. So we end up on the left, we have 45 is equal to 9b, which means that b here is going to be equal to 5. Perfect. Now we have b. We can do the same thing here to solve for a. So x is 2, that made x minus 2, 0. If we go over here and look at this equation, or sorry, look at this portion, we have x plus 7, and we can let x be minus 7. And if x is equal to minus 7, then the left-hand side we have a similar thing happening. We have 8 times minus 7, we get minus 56 plus 29 is going to be equal to a multiplied by minus 7 minus 2. So that's a times minus 9. And then we have here b multiplied by 0. Okay? And so on the left, we have minus 56 plus 29. We get minus 27 is equal to minus 9 times a. And so a is just going to be equal to positive 3. Now we know that a is 3, b is 5. We can go back and integrate. So we end up with our integral 8x plus 29 over x plus 7, x minus 2. That's going to be equal to a, which was 3, divided by x plus 7. And then we have b is 5, so that's going to be 5 divided by x minus 2. And now looking at these two, we know they're going to be integrating very easily. And so each one of these is simply going to turn into a logarithm. And if you have trouble seeing that logarithm, you could simply do the sub here. U is x plus 7. And over here you could do a different sub with x minus 2. So this one will be 3 multiplied by ln absolute value of x plus 7. And this second one will be 5 multiplied by ln absolute value x minus 2, put in the plus c. And so yes, you see, much easier to integrate it once you've done the partial fraction decomposition, and we are done. Now, let's take a look at that second method. We want to look at method 2. This one's going to take a little bit longer, but as the questions get more complicated, you'll have no choice but to use the two methods together. So what we're going to do is we're going to go back to that equation that we had before. Looking at this one right here, okay? So this is where we would branch off. We have 8x plus 29 is equal to the right-hand side, so let's rewrite that in. And we have here a multiplied by x minus 2. And we have b multiplied by x plus 7. So again, starting from this portion, rather than plugging in values of x to use, what we can instead do is we can expand the right-hand side. So here, expand the right-hand side of this equation, and we end up with 8x plus 29 is equal to a times x minus 2 times a plus b times x plus 7b. And now what we have on the right-hand side, we have these 4 terms, but we can actually sort of group these together. We can collect like terms. And I have a times x, I have b times x, so if I factor out x, I have a plus b times x. And that takes care of these 2 terms. Then we have minus 2a plus 7b, and because a and b are both constant, minus 2a plus 7b is also going to be constant. And now, all that it looks like we've done here is sort of rewrite it, and really, yes, that's all we have done. But now, what you'll notice is that on the left-hand side, we have a polynomial. This is a degree 1 polynomial. It's really just a linear function. This is a line with a slope of 8, and it has a y-intercept of 29. Well, if this is a line for every value of x, then on the right-hand side, for every value of x, this must also be a line. And so when I look at the two of them, I have here my coefficient of x is a plus b. So by equating coefficients, this a plus b must be equal to 8. In other words, the slope of the line for the left-hand side is 8, and so the slope of the line for the right-hand side must also be equal to 8. So the first thing that we get as a result of this is that 8x, or is rather that 8 is equal to a plus b. We can do the same thing over here with the constant term. This is our y-intercept, okay? It's our constant term. It must be equal to the constant term on the left, so it must be equal to 29. So we have 29 is equal to minus 2a plus 7b, and now we're going to work on solving for a and b from here. So now what we have two equations and two unknowns. We can solve for a, we can solve for b. So from the first equation, we end up getting here, if we solve for a, that a is going to be equal to 8 minus b. We can use that, plug it into the second equation, and we now have that 29 on the left-hand side is equal to minus 2 times a, where a is 8 minus b, plus 7b, and so 29 is minus 16 plus 2b plus 7b, and so really bringing this over to the other side, we get 45 is equal to 9 times b, which means that b is equal to 5. Now, technically, we already knew that b is 5 from the first method, okay, but it's nice to see, of course, we get the same answer using this method that we did in the first one. That's b. We want to figure out what a is, so we know already that a is 8 minus b, so we get now that a is going to be 8 minus 5, a is going to be 3. Okay, and so now we would finish off integrating in the same way we did the first one, remembering that we know how to do these logarithms. We would get this as our final answer. So those are the two methods, okay? Primarily you'll be using method 1, but when the questions do get more difficult, you will start to have to use method 2, likely together with method 1 in the same question. And you'll see how that works in the other examples.